All right, so Joanne, shush. Please. Should have keep it in statistic. Yeah, how was it? What is it about? What is it about though?
It's running confidence and significant. It's comparing like comparing two different means, two different portions, like with significant confidence.
Chi-square test?
Huh?
Chi-square?
No choice. Not yet.
All right. So the thing about logarithm is actually the logarithm is actually not hard. So I told you, like I actually have a funny story about my second year or first year of teaching. So I teach in Algebra 2 honor, and that's only 2 honors class I have. And I teach for whole weeks, and those one student asked me, say, what is log? And I basically don't know what to answer to that. I didn't know how to answer her because I didn't have the answer for her. So instead of saying I don't know what is log, I didn't want to show my weakness, right? Not a first year teacher. You don't want to show your weakness because your students are gonna be like, I don't know, this teacher is kind of sus, right? So I just instead of say I don't know, I kind of make fun of her. I says I've been teaching you a whole week and you still don't know this, and so that's it. But I feel like I feel horrible. I feel horrible about the situation. So every year I feel like I need to redeem myself and I need to make an amend. If I ever see her, I have to say sorry to her. And if anything, if I didn't see her, I just had to make sure I answer her question every single year. So that's my promise to myself. I have to do that because I cannot pull that shit again. Oh, sorry. Huh? Yeah. So I have to redeem myself, and so what I will do is I will explain you what is log. So one of the question that come up with is, well, first of all, before you understand log, you have to understand something called exponential function. It's y equal 2 to the x. Okay, so 2 to the x power. So you say, well, that's called exponential function. That looks like something like graph going like this, right? So, and then you say, well, what's that got to do with logarithms? And what is log, right? So first of all, before we answer that question, we need to tell you things from yesterday. So ln of x plus ln of y equal to ln of xy. And ln of x minus ln y is equal to ln of x over y. And ln of x to the y power, no, sorry, it's gonna be y ln of x to the y. And you have ln, oh, sorry, log of b of m is equal to natural log of m over natural log of b. So with those 4 different property that we can use, like couple this property here, especially those 2, and to answer that question, what is log? Log is actually interesting. Well, first of all, what's the relationship between those 2 functions? Y equal to log 2 of x versus y equal to 2 to the x. Do you guys know? They're inverse. Good. So they're inverse to each other. So what I'm going to do is I'm going to somehow convert it here. So first of all, in order to find inverse, you have to switch the x and y. So x equal to 2y. So that's the first job. Second thing is this. In order to find inverse, you always have to isolate the y. But the problem is y is an exponent. If it's an exponent, how do you isolate the y? You just take a log, but do I take the log on one side or both sides? You have to do both sides. You do something, you have to do both sides, right? So I'm going to do is natural log of x equal to natural log of 2 to the y. So natural log and log are different because one is base 10, one is base e. So I prefer using the base e one. It's just because much easier. So ln of x equal to ln of 2 to the y. Now, because of the third property, I can bring down the y natural log of 2 because I can bring the exponent down. What's nice thing about the logarithm is help you bring the exponent down, especially the third rule. So which is very, 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 very crucial. Now what I'm going to do is I'm going to solve for y. So if I solve for y is equal to ln of x over ln of 2. Now I'm going to use the last property. I'm going to say, well, that basically I can convert back into log 2 of x. So basically, in order to answer her question that I need to make a amend on is logarithm are the inverse of exponential function. Now remember, there's a lot of inverse function you deal with before. For example, let's say 10 inverse of 10 of x. So you have something like this. That just means this and this gonna cancel out each other, because if they're inverse to each other, it should get a result of whatever inside the parenthesis. So they should cancel each other. It should equal to x if they're inverse to each other. That's one of the foundational understanding for inverse function. If you put the original function inside the inverse function, it should come out with the x. Or inverse inside the original function, it's going to be the same way. It should come out with the x. So that explains that problem that both Xavier, Basil, and I think Basil asked that too, and also as Robert, is saying, hey, do you know how to do this? What is log b log b of 3? If you pay attention, b is the exponential function, right? But is b to the exponential. But the exponential is actually the inverse of the exponential function. So basically, in this case, those two are just going to cancel out and left with 1 times 3. So the answer is 3. Okay, that makes sense, right? So like I say, I think it was a very big mistake of me to kind of like say that to her. It was really bad. But we all make mistakes in life, and we had to make it better. So if she's watching, I apologize. I actually forgot her name. I don't remember what she looked like, but I forgot her name. That's probably true. But she's an A student, so she's fine. She's asked, actually at a moment in time, she asked the best question that whole year. What is log? And I couldn't answer it. It was really sad. Sad story, but life goes on. Life goes on. Hopefully we'll for the better, right? Okay, so that is anyway, that's the log story that I have. And I really think that you guys need to understand. So somebody ever asks you what is log? You have to say it's an inverse of exponential function. Okay, it's inverse of what the exponential function is. So that's to help you. Now, we're gonna help you solve couple logarithm and e problems because you need to know how to do that. They're not very hard. They use a very similar ideas. So let's start with the first one. Is natural log of 2x minus 1 is equal to 5. How do I solve for x here? Exactly. What you can do is use a property what we just learned, right? What is natural log? Natural log is log base of e, right? So can I just use the property that we just learned? E to the both sides, but it have to be raised to the exponent. It's not e times, but is to the exponent, 2x minus 1, and that's going to be equal to e to the 5. Do you see that I just raised that power to the whole thing? Now, what's nice thing is you remember this is log base of e. If that last log base of e, can those two cancel out? Does that make sense? So then there's going to be 2x minus 1 equal to e to the 5. Do I need to evaluate e to the 5? No, that's just like 2 to the 5 power. That doesn't matter. You already know what that is. You can plug in the calculator. So e to the 5 plus 1, and the x equal to e to the 5 plus 1. But e to the plus is not an exponent. So over 2. So that's a final answer here. In your homework, you're going to have a old test I give out to. It's not a test, don't worry. It's just as a homework. So as a test for you to make sure you know your logarithm skills. So this is one of the question. It's on that. You have to know it. So in pre-cal, I give a test on my logarithms. So I use that same test to give it to you. So you can practice it. And make sure you understand your logarithms. Now what happened is, some people says, can I use this way? Yeah, of course. Natural log base e. Can I do it the hard method? Since volunteer is coming, volunteer time is coming. So you say, hey, I would prefer to use this way. And that's fine. Not gonna give you the same answer. So it's actually less writing. But I don't prefer it, but it's less writing. You still solve the same problem, same way. Does that make sense?
Why is it different?
There's no different here, but instead you're using different property. The first time you use e to the both side. Second time you just convert from that logarithm form to exponential form. And they still solve the problem same way. But that's nice, right? So what happens if you have e to the 2x minus 3 is equal to 5? What happens if you have this case? What do?
You do ln to both sides.
You ln on both sides. So now you don't have to raise the power. It's just ln of 5. So ln e cancel out. So it'll be 2x minus 3 is equal to ln 5. And 2x equal to ln 5 plus 3. And x equal to ln 5 plus 3 over 2. So that's one type of questions. Am I going too fast?
No, as long as you don't spell that right now.
Now we're going to talk about one last question, which is I have to do with properties. And for me, I usually teach this question is because students need to understand two things. How to solve logarithm equations. One. How to recognize what is the right answer. Even you solve it doesn't mean they are right answer. You're like, wait, what does that mean? Yes, in math, there was extraneous solutions and the solutions. Extraneous solution should not be part of the solution. So you have to learn how to exclude the solutions if it's extraneous. So in terms of math goes, that sometimes we get this question, we can say log of x. And we get plus log of x minus 3. In parentheses is equal to 1. You say, hey, how is it possible for me to solve this equation? So I want you to guys try it. Think about what would you do to solve these questions.
What would be x squared minus 3x?
Go ahead and solve it. Go ahead and solve it.
Because you said what would you do here? I got 7 over 2.
That's not right.
I don't know what I want to do. I just did 10 on, I raised it to like 10 on both sides. Cancel it. What I did. So what do you do? What?
Oh, I think I know what you did. No, that's bad.
So what are we solving for?
Solving for x.
Oh, okay.
So yeah, you guys doing a good job by condense both. So it'd be log of x times x minus 3 first. It's called condensations. And now you have one log to get rid of. But this log has base 10 in there. So you have to know that. Sometimes it could be base 3, sometimes it could be base 4. So you can draw a heart, or you can 10 to the both sides. So that's going to be x times x minus 3 is equal to 10. Now, what Zach did is set x minus 3 equal to 10. No, that does not work. You have to make sure use a zero product property. Zero product property means this. You have to set it equal to 0 because they cannot equal to 10. It's never 10 product property. It's always 0 product property. Guys, understand, you cannot set two parentheses equal to a value. That doesn't work mathematically. You have to set it equal to 0. The reason why I set it equal to 0 is anything multiplied by 0 is going to be 0. So it's going to be x minus 5 times x plus 2. And the x equal to 5, x equal to negative 2. Now, I just teach you how to solve logarithm equations. Now, what's my second thing I told you? How to recognize which one's extraneous and why. Which one's extraneous? Negative 2. So you probably think about this looks ugly, so that should not be the answer. But looks ugly must be a reason why they are not part of the answer. Why negative 2 is not part of the answer? Huh? You can do negative log. So assume that I can. Let's assume that if I have log of some type of 10 base, and I'm going to say negative 2, and it's equal to some type of number. So if I change that, it's going to be 10 to the x equal to negative 2, right? 10 to any power does not give you a negative value, though. 10 to give you any power is going to be, for example, 10 to the 1 is 10. 10 to the 2 is 100. 10 to the negative 1 still don't give you negative value because 10 to the negative 1 is 1 over 10. 10 to the negative 2 is 1 over 100. So you say, no possible way that I can change that to become a negative. So therefore, the x equal to negative 2 is extraneous. Does that make sense? Pretty easy, right? So you just have to exclude that answer and get the answer x equal to 5. You have to know which one to eliminate though. Okay? Yep.
And then if you were to plug it in the original way.
Yep. Always plug in original to make sure it works. And both negative 2, negative 3 is, negative 5 doesn't work. Is this hard?
No.
This is just a pre-calc and algebra 2 review. And that's why I'm going to give you the test like that, but it's not a test, don't worry. Your test is going to be on calculus, so
How much was the most recent test for?
probably 100 points. I just had to scale it.
No, you got 3 left.
He told us all the questions would be.
I did tell you how the question will be. Does that mean you did well? Well, I haven't graded. How would you know?
Let's see. Did we go over the test that we did on Friday?
Huh?
Did we go over that one?
No. Okay, so what we're going to do is talk about derivative today. Derivative is actually a little bit interesting. So turns out in this case, calculus is actually easier than pre-calc because there's less rule to follow. Yep, we're going to learn about calculus, which is how to take a derivative of natural log of x. Now, I don't want to show you the proof because the proof requires you to know how to take a derivative to e to the x, which is we don't know how to do that, which is so much easier. Believe it or not, derivative of natural log of x, you just have to remember it. It's 1 over x. That's it. But you have to memorize this though. If you don't, I'll beat you. Oh, sorry, I cannot beat students.
Whoa.
I beat you mentally. Mentally. Okay. D to the dx of this content is not for kids.
We're in a learning environment.
Oh well. I only have 2 views, so it doesn't matter. Nobody gonna investigate me. So if I take a derivative of natural log u, why do I do natural log u? It's not all the time I'm gonna give you x. Sometimes I might give you sine of x. Sometimes I might give you cosine of x. Sometimes I might give you x squared, square root x. It's gonna be du over u or u prime over u. Either way is the way to think about how to take a derivative. Now I'm gonna come up with a very, very cool question in a second. And I think this question Ethan will enjoy. Yeah, because Ethan never enjoyed my class. And that's
What did you do? Like, I don't understand.
okay. So now then you say, okay, well, how do I take a derivative of natural log of x? We already know that, right? 1 over x, right? But then I want you to take a derivative of this, natural log of 2x.
If I say 1 over 2, that's when you beat me.
Yes.
Okay.
It's 2 over
I just said yes. I'm not saying I'm gonna beat you, but I'm saying yes.
Genius.
Oh, yeah, 2 over x squared. No, that's x squared over 2x.
No, it's on the top.
What's the difference between the derivative of a constant?
That's it.
Of like ln
1 over 2. 1 over 2.
Like what's the derivative of ln?
You on the right track.
2 over 2.
Yeah, me too.
What is that?
No. Okay, u equal to what? 2x. What is du? 2, right? So it'd be 2 over 2x, right? So it's like 1 over x. You're like, crap. It's 1 over x. Why is 1 over x? Why? Derivative of natural log of x is 1 over x, and derivative of natural log of 2x is 1 over x. What in the world? Do we just break math?
Yes, we did it, guys. We did it. We broke.
We don't have to learn anymore. We broke math. Math no longer exists.
Really?
No, I'm just kidding.
Oh, yeah, that's what he's graphing it.
Okay, that's graphing. It turns out I'm already 1 step ahead of you.
That's what's going on.
Wait, that's like upside down.
Well, look at the blue graph. Blue graph is derivative graph. The red graph is the thing. But the blue graph never change.
Why is the what's the rating? Oh.
So it just doesn't change the slope.
Well, why though?
Oh, because it's he's a constant.
Wait, what's a double prime?
Oh, that's a good question. I don't know what it looked like.
Don't do it. No.
No, I want
Don't
to
do it.
Is it just like
It'd be a straight line.
it's just a straight line?
Yeah.
Maybe it might be a straight line.
Oh yeah. Yeah. That's slope is insane.
Look, still didn't change. What in the world? Do we just broke math?
Are you only shifting it, or are you like actually shifting or crossing it?
It turns out the question or the question are the very, very, very simple. So I want you to think about simple things. And I explained this to you guys before. You guys, some of you guys play baseball, some of you guys play different sports. The best in the world that at doing something, like even Kobe Bryant, Michael Jordan, I don't know, best pitcher is, they all can do a very simple thing very extremely well, down to perfection. Even they stand up on the pitch mound, they will have a perfect posture. They will have a perfect posture. Even they playing golf, they will stand up straight correctly. Doesn't have hunchback, doesn't have anything. Has correct posture before you hit the ball. So the simple thing is actually a super important thing. If you ignore the simple thing, you kind of ignore everything about what's important. It doesn't matter what sport you do, and they say like Michael Jordan, the way that he practiced just a simple shot, just simple shot after shot after shot after shot. He do the same thing over 1,000 times. 1,000 free throws, 1,000 things. Like just keep on doing the same repetitions, and they can do it so perfectly. Even small things there's no smallest deviation from each shot. How do we do that in math is to think about the simplest things. And that's what the greatest people that they can do is they can think of the simplest thing. So how do I explain to you why is derivative of natural log of x equal to 1 of x? Zach happened to know. Yes, Zach.
If you like split it up, then like the derivative of ln2 is 0.
Do you see what you say?
And then you add the ln plus ln derivative of ln x, which is 1 over x.
What's the derivative of this? 0.
Oh my god.
Right? What is derivative of this? Is 0, right? So this one is this. If I take a derivative of this, that's just gonna be 0 plus 1 over x, and that's what 1 over x still 1 over x. That's matching, right? It's a magic. No, it's a things like a lot of things like this. Think about some of the things. Zach was the first one to think of, even like 10 minutes ago when we ended this question. He's actually asked me what's the derivative of natural log of 2. And I knew that he got it. So a lot of things is like just think about simple things. Don't think about something too complicated. It's not complicated thinking. A lot of things can be easy to understand if you think about simple thing. What would this thing normally happen? So now we're going to think about simple things when we're doing stuff, right? So think about algebra before you think about calculus. How do I do derivative of this? Y equal to natural log square root of 1 minus x squared. Think about the simple things first. Think about what we learned yesterday and think about what we learned today. How do we take a derivative of these functions?
Can you explain why? Or else I would text you. No, we're getting.
Okay. So let's think about simple thing. What is simple thing that we can think of? A to the m over n equal to n of a to the m, right? This definition of radicals. And can I rewrite this to 1 minus x squared to the 1/2 power? Can I move to the front? Can I just don't worry about the 1/2, just take a derivative of natural log of 1 minus x squared. Now what we're gonna do, u equal to 1 minus x squared, even though I don't usually do the step, u prime is equal to negative 2x. So that's gonna be 1/2 times negative 2x over 1 minus x squared. Does that make sense? And 2 cancel out, be negative x over 1 minus x squared. Finish. Think about the simplest things, right? Think about the simplest thing before you're doing something. Always think about, it didn't matter what you do. It didn't matter what sports or things like that. It's always think about what the simplest thing can happen. Don't try to overthink it. Try to do things like this perfectly. So of course now I'm going to give you next questions. So next question is, hey, do I know how to take a derivative of this?
Have mercy in this man. Oh, you think you're done? Oh, okay. So you do that. Everyone, let's do it.
Tomorrow's a short day, so I'm just gonna add one more step toward this, which is super easy as well.
That's normal. Yeah, but normal is always straight, no matter what. It does. Yeah, we'll get less straight. If it's. No, the more you zoom out, the less straight it is. I'm only being the ground.
1%.
Yeah, my bad. What's the computer around? How do you? Which one? Right there. Not there. I see that too.
And you don't need to simplify too much. You just need to take a derivative. That's it.
That whole. Oh, that's it. Okay.
That's what you
You say five?
So okay, but so the first step is ln of parentheses form right here. Where 1/2. What? You can also take half. What do you mean by put the derivative up? You can put 2x 1.
So let's do algebra, right? So can I say it's 1/2 of 4 minus 3x squared? Can I say minus 5 ln of 5 minus 2x? And then can I say take a derivative, dy dx is equal to 1/2. Derivative of this one is going to be negative 6x over 4 minus 3x squared. Minus 5, what's derivative of 5 minus 2x? Which is going to be negative 2 over 5 minus 2x. So it's negative 3. If I simplify this, it's negative 3 of 4 minus 3x squared plus 10 over 5 minus 2x. You're done. You don't need to do any more work. That's it. Good. See, if you keep on write down stuff in class, you do so well. Before you just like, yeah, I get it.
Yeah. But now you actually get it.
Now you actually get it. Huh?
Oh no, where did the x go in the first one?
Which x?
It said negative 6x.
Oh yeah, I'm missing an x. Thank you. I did miss an x. You have a good day. The class ends in 1 minute. I finish on time.
First time ever that we finished on time.
Yeah, if I don't talk about nonsense, right? Most of the time I just